and chaining. This is one of the techniques that we use for hash algorithms. So instead of doing the linear probe or quadratic probe or random probing, random is find random location to put the weighted escalation, or use the quadratic formulas to do weighted escalation. We can use buckets and chaining with escalation. So bucket is collection of elements associated with a particular hash location. A chain is linked list of elements that share the same hash location. So by looking at this handling collision by hashing with the buckets, we create an array, right? 2-dimensional arrays, or just array with an array that store, like for example, we want to insert 7003. Hash function say, hey, index is 3. And when we get into that, it's no longer null. We no longer want to do linear probing to 5, since we know there's a problem when we remove, that we not support remove operation. So we said, then we just create a bucket. So just go to the next one inside that index, the next column. This is 2-dimensional arrays. And if there's space to add, then we add it there, because it's still null. Now when you do search, you just search through the buckets, right? And remove, just remove through the buckets at its index location. So same technique with the chaining, but the chaining we don't use the array, we just use the linked list. So we have the list, we insert into 3 index, go to 50,003. We have the linked list of the 77,003 that point to the next values. So that's the chaining. So to use that to solve the collision of hashing. So that's all about the hashing. So now we just want to show you that Java is already have the hash table right in the libraries that you can use. Class name hash table. Right, use hash technique to support storing object in a table. So we have add, contains, and remove. So let's look at the hash table library here. So you see that hash table, this is a class. This is a generic that based on the key and values. They are generics. It can be any type of key, any type of value objects. Right, so for example, if I want to have the key as string and the value as integers, and this is hash table as numbers, new hash table, we create a new hash table. We can put the elements into hash table by using the operation put and giving the key to it and the values to add. So these are the key and the values. Okay, and if we try to get, right, they have put operation and get operations. So get like search and see if it contains 2, right? So it's going to return their values back, which is number 2 as an integer. So if we're not finding it, then it's just if n not equal to null is print. So otherwise we're not printing it out. So that's how we use it. Look at the constructor, default constructor. You can initialize the size to increase the size. Default capacity is 11. Okay. So we also have load factor. Load factor is like percentage, like 75% here of the occupied the size vacancies, right, as 25%. And hash table that we look at. So we have clear contains, right, contains key, contains values, elements return an enumeration of the values in the hash table. Entry set returns set of view of mapping contained in the maps, right. Look at equals, get, we can get, pass a key, get a value back. we can get the hash code, return the hash code value for this map. It's empty, is the hash table empty? Returns an enumeration of keys in this hash table. Key set returns set view of the keys contained in the map. We can put, we look at it, put. We can put all. Rehash increases the capacity of and internally reorganizes the hash table in order to accumulate and access its entire more efficient. So when you keep add, sometimes you want to rehash it to make it more efficient. Like because it can create clustering, like we discussed on the slides. Remove. We can remove object now since we have the collision technique to support. And hash table already implement those. So then you don't have to worry when you use hash table. This technique. Size, return the number of keys in the hash table. 2 strings, just print them all out, right? And values, return the collection of the hash table. Alright, so we can use that. It's already supported in the library. So the library includes several other collection classes such as HashSet2 that provides an ADT whose underlying implementation uses the process described in this section 2. So let's look at HashSet. So we look at hash table already. So hash table, we have key and values. Hash set, this is a generic as element. So this class implements the set interface, backed by hash table. It makes no guarantees as to the iteration order of the set. It does not guarantee that the order will remain constant over time. The class permits a null element. So, contains basic operation add, remove, contain, and size. And assuming that the hash function disperses the elements properly among the buckets. So we talk about buckets. So assume that it's going to disperses the elements properly. So they use the bucket technique here. So when we create, you can just create from the list of collections. You can initialize capacity and load factor. Same add, right? Clear, clone, contains. So hash table you use key, but this one you just add the elements right away. No key, that's a different hash set and hash table. We have remove and size. Java obtained class exports a hash code method that returns an int hash code. Therefore, all Java objects have an associated hash code. So we talk about object class export a hash code. All the object has a hash code, right? The standard Java hash code for an object is a function of the object's memory location. So let's check. If we do object Java doc, the object is the root of all Java classes. You see they have the method hash code, return the hash code value of that object. So all the classes, all the object in Java returns hash code, right? That return an int hash code. Therefore, all objects have an associated hash code. Right? Standard Java hash code for an object is a function of the object's memory location. It's just give the memory locations. That's what it is. For most applications, hash codes based on memory locations are not useful. We never use them. You can see that most of applications. Therefore, many of Java classes that define commonly used objects, such as string and integer, override the object class hash code method with one that's based on the contents of the object. If you plan to use hash tables in your program, you should do likewise. And that's the end of this chapter. Chapter 10. And that's the end of this data structure class 2.